Okay, we're going to go over a little bit more about curve fitting with polynomials. So here we have our problem. So first thing we're going to do is get the data into the calculator. A reminder that when we have years, you can't put 1988 and so on into the calculator for the year, for the x values. So since it says certain years since 1988, that means that we are taking 1988 to be year 0. And then 1990 is 2 years after that. Notice 93, it's not 3. From 93 to 88 would be 5 years past. This would be 7 years since 1988. This would be 11, and then this would be 17. So I'm going to go ahead and take my calculator and plug that stuff in. So I already did that just to save time here in the video. So I hit Stat and then Edit, and I cleared my list out, and then I put that data in. So now what we're going to do is we're going to make sure that our calculator has the r² value showing up. So you should only have to do this once, but click the Mode button on your calculator. And so Mode is right here next to Second. And you're going to come down here and make sure that it says Stat Wizards or Stat Diagnostics on. Okay, so right there where it says Stat Diagnostics, this one needs to say on. All right, so now I'm going to go to Stat. And in this case, you can see it says just find the best model. So what I'm going to do is go to Calculate. And I'm going to try a cubic regression first. So we have L1, L2. We're going to restore the regression in Y1. So we're going to go alpha trace, and that's how you can get the Y1 to pop up. And we're going to hit calculate. And I see my r² value is 0.9. We want this to be as close to 1 as possible. So I'm going to go ahead and try it again with a quartic and see what I get for that. So stat, calculate, I'm going to do the same thing again, except this time I'm going to do number 7, quartic. Again, I'll store my equation in Y1, so alpha trace, and calculate. And don't hit enter or anything. If you just scroll up and down, you're able to see the values, and you can see that r² value is a lot better. So 0.985, we're getting really close to 1. So quartic is the best model. So what you'll do is you will round each of these numbers to like 2 decimal places when you go to write it down. So it would be y equals, and I know I'm going to lose it there on my screen, but I got 4.07 x to the 4th minus 123.18 x to the 3rd plus 1079.55 x squared minus 1912.70x plus 1971.91. All right, but now what we really want to do is estimate the value of the stock in 2010. So first of all, I need to figure out when 2010 is compared to 1988. So I'm going to go ahead and take 2010 and subtract 1988, and I get 22. So I want to calculate what the value is in year 22. So I'm going to go ahead and hit my y equals. You can see that the graph is there. I need to get rid of what's in my y2. There shouldn't be anything there. And I'm also going to go into my stat plot. So I'm going to hit second y equals and hit enter. I want to turn this plot on. And this way I'll actually see the L1s and L2s show up. So I want it to look exactly like that. Once you turn it on, when you go to your y equals, you can see that that plot is on. So this plot up here means it's graphing the dots. This means it's going to graph the line through those dots. Remember, we have to zoom it to the data, so we're going to press zoom, and the one that you want is zoom stat, which is zoom 9. So it'll automatically fit the data for you, which is nice. And you can see that that's not a bad model. It's going through most of those dots and showing us pretty well how the data trends work. Now, what we're trying to do is figure out the value in the year 22. So what I need to do is calculate the value at 22, but if I try that right now, it's not going to work. I need to take my window, and my x has to go past 22 to be able to do that. So I'm just going to adjust that window to like 25, hit graph again, and you'll see it'll go beyond our points and it'll keep extending onward. So now what I'm going to do is go to second, calculate, and I want to know what is the value in year 22, which represents 2010, and I get that answer. So that would be the number that we would write down for our answer. Okay, so here's the second one. It says to estimate the amount of lumber that can be harvested from a tree, foresters measure the diameter of each tree, and we're trying to find the best polynomial fit where we have the diameter, and this tells us the volume of hundreds of board feet, so how much wood is going to be able to be harvested. And then specifically, we want to know if the diameter is 35 inches, how much would we be able to get from that? So I went ahead and already put the data into my calculator. So I hit Stat, Edit. I went up here and hit Clear, and then I put it into both L1 and L2, and I put in my new data. I'm going to go to my y equals, and I'm going to clear out whatever's in there because I don't want a previous problem in there. And I'm going to go ahead and do zoom 9 again just to see what this data looks like, to give me an idea of what kind of model it might be. So this is what I'm looking at. I see that both ends are kind of pointing up here. I can see that it dips down a little bit. So I'm going to try quartic and cubic and kind of see which is the better r squared. So I'm going to start with the cubic function. So I'm going to go stat calculate. And I'm going to go to cubic. So you want L1 and L2. In case this is the best one, I'm just going to alpha trace to store it. And I'm going to hit calculate. And you can see that that's pretty good. My r squared is 0.99. Now I'm going to go to stat calculate, and now I'm going to do quartic, which is number 7. So alpha trace and calculate. And again, don't hit enter or anything, just hit the down key, and you can see that r squared value. And the quartic is a little bit better of a model. So we're going to go ahead and write it down. So again, we start with the a. This is what goes in front of the x to the 4th. Now, what that e negative 4 means, that means, so don't ignore that. This isn't negative 6.49. It's negative 6.49 times 10 to the negative 4. So I have to move this decimal 4 places to the left. So this would be 0.0006. And then this would be 0.08. You don't see any more of those e's, so I'm not going to have to move that decimal. So if I go to write this down, it would be y equals negative 0.0006 x to the 4th. Again, that's 6e to the negative 4. I just moved the decimal 1, 2, 3, 4 places. Then plus 0.08 x to the 3rd minus 3.55 x squared plus 69.11 x minus 491.39. So I just put those numbers in, and now I'm going to go ahead and hit zoom 9, and I can see my graph. And since I stored the equation, I can see the model going right through there, and it goes through those dots pretty nicely. And then it asks me, what is the volume if the diameter is 35? So I want to put a 35 in. Well, 35 is already within the range, so I don't have to extend my window this time. I can just do second calculate, and I want to calculate the value at 35. And the answer is 187.69, so about 188 board feet. So 35 inches will get you whatever we just said, 188. And it says hundreds of board feet. So 180 hundreds, so 188,000 board feet is the answer. Here, our last example, we have Braden jumping off a cliff into the ocean while vacationing in Hawaii, so doing some cliff diving. This is the height after t seconds, so this means this is the starting height. So at 0, he was 480 feet off the ground. Then he went ahead and jumped up into the air, went a couple feet up when he jumped, and then at 2 seconds, he's down to 452, at 3, he's down to 390, and at 4 seconds, he's only 296 feet above the ground. And so what we are going to do is go ahead and graph this. So I went into my stat key, I hit edit. I went up here and hit clear to get rid of what I had before, did the same thing on the L1, and I went ahead and put in my data. So time is the X value, the height is the Y value. And I'm going to go into my Y equals, always clear out whatever's in there, you don't want another equation. And I'm going to do zoom 9 just to see what this data looks like. And you see it makes an upside down quadratic. And anytime you're doing some kind of problem with something being a projectile, so somebody jumping in the air or throwing something in the air or a golf ball in the air or a baseball in the air, it's going to follow a projectile model, which will always be a quadratic. So I really don't have to guess here. I know that the best model is quadratic. So I'm going to go to stat, calculate, and I'm going to do number 5 for sure. There's no question here. And I'm going to store this in alpha trace. I'm going to store it in Y1 and hit calculate. So here's my equation. My A value is -16. That is a constant that has to do with free fall. And then 18 and then 480. So the equation is the height at a given time. So instead of f of x, I'm using h of t. It's -16. And again, instead of using x, I'm going to use t, because t is actually, the x value is the time. So plus 18t plus 480. Right? So there's my curve. And the question says, how long will it take Braden to reach a height of 150 feet? So I know I want 150 here. The question is, when does that happen? So I'm not plugging in a 150. I'm not talking about in 150 seconds. I'm talking about when will the height be 150. So I'm going to go ahead and hit graph so I can see it. And again, this tells me my height. Well, I want my height to be 150. So what I'm going to do is hit y equals, and I want the height to be 150. So I'm going to put 150 in there and hit graph. And okay, nothing's showing up. So let's check our window. The problem is my Y minimum went only down to 264 because it fit the data. I need to see lower than that. I need to see down to 150. In fact, I'm just going to put like -5 because I just want to see all the way till it hits the ground. And I'm going to go up by 50s because I see this is a really wide range. So instead of going up by 1s, I'm just going to go up by 50s. So I'm going to hit graph. You'll see our data coming in. And now I see this line. Okay, well now I have another problem. I can see the line, but I need to be able to see where they cross. So I need to go into the future just a little bit. So on my window, my X maximum needs to be a bigger number. So I'm going to go to maybe 10. Hit graph. And now I'm going to calculate that intersection point. So second, calculate intersection. We've done this before. So just get close to it. So that's pretty good. Enter, enter, enter. And you can see when you get a Y value of 150, the time is 5.1 seconds. So at 5.1 seconds, it equals 150. And you may just want to draw that little sketch like that to remind yourself that that is what you did to find the time for 150.